Turtles have been around for, what, over 220 million years? I mean, they're the planet's ultimate survivors. But how? How have they pulled it off for so long? Well, today, we're going to do something cool. We're going on a journey inside that incredible shell to uncover the biological secrets to their amazing endurance.
Okay, first things first. Let's get right to the question that every single one of us had as a kid. Thanks to all those cartoons. Can a turtle really just pack its bags, pop out of its shell, and walk away? The answer? Well, it's probably not what you think.
Yeah, that's a hard no. And the reason why is absolutely mind-blowing. See, that shell isn't some mobile home a turtle carries around. It's literally part of its body, fused to its skeleton. So asking a turtle to leave its shell, that's like asking you to just slip out of your own ribcage. It's impossible.
And I mean that literally. The top part of the shell, that's called the carapace, and the bottom part, the plastron, they are physically fused to the turtle's spine and its ribs. And get this, the shell has nerve endings. A turtle can actually feel you touching it. It is a living, breathing, feeling part of its body. All right, so now that we've established the shell is the skeleton, let's go a layer deeper. Let's take a look inside and see the incredible engineering that's packed into this tiny space. And you're about to see there is absolutely zero room to waste in there. So, right up at the top, you've got these huge, spongy lungs. Tucked in there is the heart. Then you have this massive liver, followed by the stomach, intestines, and all the other essential organs. I mean, look at that. Everything is just so precisely and tightly packed. It's a masterclass in biological space saving. Now, right in the center of this super efficient system is the heart. And this isn't just any heart. It's a powerful, highly specialized engine. And it's the key to one of the turtle's greatest superpowers, its ability to spend an insane amount of time underwater. See, unlike us mammals with our 4-chambered hearts, a turtle has a 3-chambered one. Now, what does that mean? It has 2 atria, but only 1 ventricle that's partially divided. This design might sound a little different, but it allows the turtle to do something truly amazing with its blood flow. It is a total game changer for an animal that dives. It's a process called a shunt. So when a turtle dives, its heart basically becomes this incredibly smart plumbing system. It can actually redirect blood away from the lungs, which are useless underwater, right? And send that oxygen-rich blood straight to the body and brain. This is how it conserves that precious oxygen, letting it stay under the surface for way, way longer. Okay, so we know they can conserve oxygen like pros, but that just leads to an even bigger puzzle, doesn't it? How does an air-breathing reptile, whose ribs are literally fused to its shell and can't move, manage to become such a master of the underwater world? Well, first, let's talk about how they breathe air on land. Since they can't expand their ribcage like we do, they've evolved this genius workaround. They use their internal organs like a giant piston. A set of muscles pulls all their organs down, creating a vacuum that sucks air into the lungs. Then, another set of muscles shoves everything back up, pushing the air out. It's such a clever solution to a very unique problem. But again, that's for breathing air. So how on earth do some of these species stay underwater, not just for a few minutes, but for hours? Or how do they hibernate for an entire winter at the bottom of a frozen pond? Where's the air coming from? Well, it turns out they have a whole survival toolkit for this. They're great at storing extra oxygen in their blood and muscles. They can also do something called metabolic depression. Basically, they can slow their heart rate and energy use down by a jaw-dropping 95%. They can even absorb a little bit of oxygen through their skin. But they have one more trick up their sleeve. Or maybe not their sleeve. All right, you might want to sit down for this one. Yes, you are reading that slide correctly. The official term is cloacal respiration, but everyone knows it as butt breathing. And no, I am not making this up. Some freshwater turtles have these highly specialized sacs in their cloaca, that's their all-purpose rear opening, that can pull dissolved oxygen straight out of the water. It is a brilliant and, let's be honest, a completely wild example of how far evolution will go to solve a problem. So with that in mind, let's shift gears a little. How does this unique anatomy, this whole survivalist blueprint, influence how a turtle eats, how it sees the world, and even how it reproduces? Because it all connects back to this ancient body plan. For starters, turtles don't have any teeth. Instead, they've got this super powerful, sharp beak. And what they eat completely changes their internal plumbing. Herbivores, like your average tortoise munching on grass, need really long intestines to break down all that tough plant fiber. Carnivores, on the other hand, like snapping turtles, have much shorter digestive tracts because meat is easier to process.
And their reproduction is just as fascinating. For a lot of species, the sex of the babies isn't decided by genetics, but by the temperature of the nest. Isn't that wild? Generally, warmer nests will produce more females, while cooler nests will give you more males. So let's put it all together. We've looked at the incredible shell, the super efficient organs, that amazing three-chambered heart, and those unbelievable breathing tricks. When you add it all up, you finally get the answer to the biggest question of all: why on earth do turtles live so long? It's really a combination of all these incredible features, a perfect blueprint for longevity. Their shell is the ultimate defense. Their slow and steady metabolism means less wear and tear on their bodies. And of course, their remarkable heart and their mastery of oxygen make them unbelievably resilient to all kinds of stress. And all of this incredible biological engineering adds up to one thing. While it varies by species, many turtles can easily live for over 100 years. 100 years! That makes them some of the longest living vertebrates on the entire planet. When you really think about it, the turtle isn't just another animal. It's a living, breathing testament to evolutionary success. Its body is a complete masterclass in biological engineering, a design perfected over 220 million years. And that leaves us with one final, important thought. This ancient design is perfectly built to survive natural pressures. But what happens when this 220 million-year-old blueprint comes up against the unique, rapid challenges of our modern world? What does the future really hold for this absolute master of survival?